Oh, hi. You're probably wondering what I'm doing. How I'm writing backwards? Or am I writing normally? We'll get to that part later. It's all part of what we're talking about today. Technology. And the chemistry behind it. Oh, and by the way, you know that thing you're watching this presentation on? It's called your cell phone. Or maybe it's your computer. Or even it could be your TV. Whatever you're watching this on, they're all part of the technology family. Now, technology is all around us, but have you ever wondered how we got here today? Well, we're going to go way back, and we are going to see, drumroll please, the chemistry behind technology. Boop, boop. Let's dive into my presentation and explore just what that is. Technology impacts our lives in many ways. It's revolutionized our world and daily lives. Heck, you don't even need a dictionary. That's not a dictionary anymore. Now with phones, there's your phone. You can use Siri, or for a computer, you can use Google to find what you're looking for words much easier. And that is so much easier than using a book. What's behind all this technology? The microprocessor. That is the brains behind all of this. But what's the main ingredient, you ask? Well, that is silicon. Silicon is the 14th element on the periodic table. It's 1 proton heavier than aluminum, but 1 proton lighter than phosphorus. Silicon is the basis of all current computer processors. Now, I know you're probably wondering, what makes silicon so special? Among silicon's most important features is that there is a lot of it all over the world. After oxygen, it's the 2nd most abundant element in the Earth's crust. But hey, don't expect to just find it lying around anywhere. Silicon is almost never found in a pure state in nature. It pretty much always comes as a compound with other elements. It's most commonly found as silicate and silica. Silica, in a rough and highly contaminated form, is the primary component of sand. That's right, you heard me, sand. You know, like at the beach. Silicon compounds have a wide variety of useful properties, mostly because they can bind other atoms very tightly and in complex arrangements. This is why silicon is a perfect element to use as a basis of a computer transistor. Now, inside the microprocessor, there are billions of transistors. 114 to be exact. Wait, 14 billion to be exact. they need to be turned on and off at all times. That's right, at all times. They require a semiconductor, which is a substance with resistance between that of a conductor and an insulator. Conductors allow for electrons to move very easily, while insulators resist the flow of electrons, so it does not allow electric current to pass through it. Silicon isn't the only semiconducting substance on Earth. It's not even the best semiconductor on Earth. What it is by far the most abundant semiconductor on Earth. Silicon is readily available all over the world. You don't need to do months of expensive and polluting treatment just to get some. It's easy to work with, and most importantly, scientists have come up with reliable ways of growing it into perfectly ordered crystals. In modern computer chip manufacturing, these crystals are then sliced into thin wafers, then engraved, processed, and treated in sometimes hundreds of different ways before being diced into the individual die and packaged into commercial processors. As we've explained, the connection between chemistry and technology comes about through the materials, process, and packaging technologies used to fabricate the devices we talked about earlier. Today, everything is going electric. Cars, planes, you name it. And now there are new compounds that withstand extreme heat and electricity that could lead to next generation storage devices. A new type of polysulfate compound can be used to make polymer film capacitors that store and discharge high density of electrical energy while tolerating heat and electric fields beyond the limits of existing polymer film capacitors. Society's growing demand for high voltage electrical technologies, including pulsed power systems, cars, and electrified aircraft, and renewable energy applications. These require a new generation of capacitors that store and deliver large amounts of energy under intense thermal and electrical conditions. Researchers at the Department of Energy's Lawrence Berkeley National Laboratory, Berkeley Lab, and Scripps Research have now developed a new polymer-based device that efficiently handles record amounts of energy while withstanding extreme temperatures and electric fields. The device is composed of materials synthesized via a next-generation version of the chemical reaction for which 3 scientists won the 2022 Nobel Prize in Chemistry. Now, I know there's so much more information out on the internet about scientists testing, technology, blah, 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 but I don't want to bore you with so much of that because that's not what I'm here to do. So anyway, thank you. Oh, I almost forgot. How am I writing backwards? Well, it's just called a light board, which is basically a piece of glass with LED lights that just gets flipped around with lots and lots of editing effects. You know. Anyway, so thank you for watching, and let's hope you learned something new about the chemistry behind technology. Peace out, y'all.